it's good to see you here, and I see that you have already started the chat and all that. I shared a couple of tests in the WhatsApp group that we have, so make sure that you attempt them today if you haven't. Although I would suggest that every test that I give, you should attempt it before you join the class. If you are not in the group, I will share the link right now, so you can join the group. Just give me a minute. Yeah, so I will be sharing links for questions and everything. The tests that I give after every class. Remember that there will be a short test after every class that you have to solve before the next day's class. So this is the group. Make sure that you join it so that you can get regular updates regarding whatever topic we are studying that day. Because this is an optional class, you can join it if you want to review that particular topic. If not, maybe you can find a better use of your time where you're studying, where you're solving other past papers. I know we're short on time, so every minute counts, and all the efforts should be focused on where you need them to be. All right. Now, coming back to the topic today, it is actually a very interesting one, and that is experimental techniques. Now, experimental techniques is a very wide topic, and it's important that we understand the scope of this thing in O levels and IGCSE. There are many changes in O levels and IGCSE, so I will be telling you where what thing is relevant to IGCSE and what thing is relevant to O levels. They're slightly different. A few extra things in IGCSE. Also, O levels people, just a hint that if you are actually going for ATP, although Cambridge has offered exemption this year, so if you're not taking that exemption for whatever reason, then it would be a good idea to test your skills using paper 6 from IGCSE. IGCSE has always had a better, more rigorous testing for experimental techniques. Their ATP exam questions are much better, I would say much harder or more thought-provoking than O levels in many papers. So if you have time, and you should make time, try to attempt paper 6 for IGCSE whenever you're preparing for your ATP. Walaikum Assalam, Harun. Alright, so first thing, we are going to deal with how do gases work. So I told you yesterday that if you understand one state of matter and then change that, or find the spectrum or how things change for solids from there, you will be easily able to do that. So here's the thing. Gas laws, there are 3 of them in our syllabus, although there are technically 4. So, but the names of these gas laws, you don't need to remember them. But of course, it helps build that connection. In the exam, they're not going to ask you directly what the law is or what does it say. They're only going to test implications of the laws. So here's an idea. For example, the first one, which is Boyle's law, it says that pressure is that inversely related to volume. Now, here's the thing. Kinetic theory told us about distance, motion, kinetic energy, and forces of particles. Now, pressure, volume, and temperature, those are the 3 macroscopic things that you can actually measure using your everyday equipment. And we will talk about what equipment you need. So pressure, volume, and temperature, they are related to the microscopic world, the particles. And when it comes to gases, how do these things change or what affects these things? So pressure comes from collisions between particles. So mind the spellings. So collisions between particles, that's what drives the pressure. So if you have higher number of collisions, then you have a higher number of a higher pressure value. Volume comes from distance between particles. If the particles are far away, then the distances between them are large, which means the volume of the total gas is going to be large. If the particles are close together, if they're confined to a smaller space, then the volume will be small. So that's what happens. When you increase or decrease the volume, this is what happens at the particle level. And temperature, as you all know, temperature is average kinetic energy. So I'm going to use these symbols for average. So it is related to average kinetic energy of the particles. So here's the thing. In the exam, they will ask you, in theory questions, they will ask you, how does affecting one of these change the other one, or what is its effect on the other one? So it's important to understand the laws and their implications. So the first law is pressure is inversely related to volume. Second law is pressure is directly related to temperature. And third law is that volume is directly related to temperature. Similarly, the fourth law, which isn't usually taught in O levels or IGCSE, but I personally think it's very important to know it, that is, volume is directly proportional to number of moles. So these are Boyle's law, Charles' law, Guy-Lussac's law, and Avogadro's law. Now, here's the thing that is important for them. All of these laws work individually, and in O levels or IGCSE, they will ask you about individual laws, provided one thing is kept constant. The fourth or the third thing in here is number of moles and the pressure, volume, and temperature. So if you're talking about pressure and volume, then temperature is constant, which means it's not changing, which means no matter what you do, that thing is remaining the same. It has no implications. When pressure and time are being discussed, volume is constant. When volume and time are being discussed, pressure is constant. And when volume or number of moles is being discussed, both temperature and pressure is constant. Okay, so we are talking about these things as constant, they are not changing, and so we are able to figure out what happens to one when it affects the other. So the relation is pretty simple. So how does the examiner test you about this in paper 1? They will tell you that a volume is decreased, and now you have to find an option that deals with this one. So for example, they say the temperature is increased of a gas syringe. What happens to the volume? So obviously you know it's going to increase. They will give you some value, you can figure it out. Sometimes they say that a gas syringe was heated and the plunger went back, or the volume increased. Explain why, or give a reason why, or which of these statements perfectly or best explains this. So obviously you have to see that we changed the temperature and it changed the volume. So we are talking about the third law here. Pressure remains the same, right? So to keep the pressure same, that is why the volume changed and it plunged from one to another. Okay, so it's important to understand how these things work. So that's the first idea in the exam. Now, in paper 2 or for O levels or paper 4 for IGCSE, where they talk about the reasons for this, they might ask you a question like, what happens, or explain why, or they might also ask you describe and explain why the pressure, how the pressure changes when volume is increased. So then you have to give a reason, because the description part tells you that tell me what it is, and the explanation part tells you that explain, give a reason, right? So here's the thing, you have to follow this format as I've told you. So for example, they say what happens, or describe and explain the effect on pressure when volume is increased. So remember this thing, you're increasing the volume. So start over here. And then what does that mean? If you're increasing the volume, you're increasing the distance. So that's your path. The volume, when the volume increases, the distances between particles increase, or the particles go further away from each other. And then you have to end up with pressure, right? So the collisions between particles reduce, are less frequent. So the pressure falls. What have I done here? I have found a route from volume to pressure by integrating the reason behind it. And that reason is important. And this is a very sound explanation of it. I'll give you another example. Let's suppose the examiner says, describe and explain what happens to the pressure when temperature is decreased. So here's how we can answer it. So we'll start with the temperature idea. We'll say that when temperature is decreased, the kinetic energy or average kinetic energy of particles decreases. So the collisions between them are not as frequent. So the pressure decreases. So I am making use of this law, but I am also phrasing it in a way that there's coherence in my answer. So for theory paper, this is super important. Okay, so I'm going to give you two questions. Try to answer them. So for example, here's a question that describe and explain what happens to the volume of a gas when temperature is increased. That's your first question. Take a minute, answer that. All right, so here's what you should have answered, or your answer should be similar to these things, and you should have used the keywords. So, how I would answer is that we have to describe and explain, right? So, I will first say that volume increases. Okay, examiner will also say that pressure is constant. So, I'll say volume increases. I've done the description part, I've described it. Now, I have to give a reason. I'll say that when temperatures increase, the average kinetic energy of particles increases. The particles go further away from each other, increasing the volume. Alright, so that's a good progression. Now, I'm not saying that that's the only answer you can give. Of course, you can phrase it in your own words, and that's your choice, whatever you want to say. But make sure that you use these keywords so that you score the marks that you need. Again, the purpose of these sessions is to make sure that you understand the concepts and you get the marks. Of course, I will hopefully do some lessons on just the concept part, so your foundation is as strong as you need. All right, so that is the gas laws. The second thing that I want to talk about is how do we do measurements in lab. And before we do that, we need to know what a pure substance is. Now, pure is a term we use all the time, but pure in the sense of science or the way we are using it is slightly different from what we use. So, for example, if I squeeze some oranges and the juice that I get, I don't add sugar to it, that is pure orange juice. But that's a layman's understanding of what purity means, because as far as chemists are concerned, it's still a mixture of many different things. There's vitamins, there's protein, probably, there's carbohydrates, definitely, there's fiber in it, there's water in it, there is sugar in it, natural sugar, there might be some salts in it, or mineral salts in there. So there's a lot of things in there. So what exactly is a pure thing from a chemist's perspective? A pure substance contains only one kind of particles. Now that is a word that we used yesterday, and we introduced it yesterday in kinetic theory, that there are particles that make everything up. Now we are classifying those particles. We don't have to get into what those particles are, or if there are multiple kinds of particles. There are, we'll talk about that. But for now, we just need to know that there's only one kind of particle. But of course, if there's one kind of particle, the behavior is also going to be the same. So here's the thing. A pure substance shows up in three different ways. Number one, it has a fixed melting point. Now I'm writing MP, but you can't do that in your exam. And boiling point, which means that if you want to know whether a substance is pure, just melt it. Of course, don't do that with your jewelry or something if you want to know if it's pure gold. But you can melt a pure substance to see if it melts at a fixed temperature. Again, I'm confining myself to O levels and IGCSE concepts. Your practical experience might have been different. In fact, it should have been different. Similarly, pure substances have a fixed boiling point, which means if you boil them, they boil at a constant temperature. Remember the heating curve from yesterday? We had this thing here, right? The flat sides over here, this one and this one, is telling me that the temperature is constant, it's not changing. And the reason for that, we talked about it yesterday, was that energy that you give, that you're still heating it when you're melting it, the latent heat, that is being used to overcome the forces. So it's not converting into kinetic energy, it's not raising the temperature. Okay, so that's the one thing. Second thing is that whenever you have a pure substance and you're able to dissolve it into a solvent, so it's important, it dissolves into a solvent, then it gives a one spot on chromatogram. So when you do chromatography of this thing, it will just show up as one spot. If you have an impure thing, it will show up at multiple spots. But if you have a pure substance, it will show up as just one pure dot. That's it. So that's the criteria of purity. So you should be able to interpret simple chromatograms that you get. For example, how do you do chromatography? You dissolve that thing, and then, so you dissolve that thing. Here's a paper on which I dissolved it. So a few important points. Number one, the baseline should be drawn with pencil. So this is baseline. If you are going to draw the diagram in exam, make sure that you draw the baseline, you label it, and mention that it is with pencil, either on the diagram or on the space that you have for writing things. Now, obviously, you will dissolve it into, you will dip that in a solvent, and in that solvent, the solvent level should be below the baseline. The solvent can be below this thing. It cannot be above it. Why? Because if this is a spot that I want to check if it's pure or not, then my solvent should not be able to dissolve it while it is on the paper. What it will do is the solvent will dissolve into the paper and rise up through capillary action. You don't need to know that word. And then when the solvent goes up, it reaches up to maybe this level. Now the solvent is going up, it will dissolve this thing as it passes through it and will make it go with the solvent. And obviously, if it is soluble, it will move, it will go away from here, and it will show up as a spot somewhere. Now this spot tells me it's a pure substance. It is only showing me one spot. I can calculate this RF value of this thing. What is RF value? RF value is a ratio. So I measure the distance from solvent from baseline to the spot, and I divide it by the distance from baseline to the solvent front. And if you're going to draw it, make sure that you label it as well. Now that's a ratio. Now in MCQs, they might test you that where should I start this? So always start from the baseline. Always end at the spot or the solvent front. Don't go above it. Don't go to the top of the paper or anything. You don't need to do that. Now, if this was impure, then what will happen? If this spot was impure, then it will show up as multiple spots. So maybe this will go away and it will show up as 2 spots. So multiple spots show it's not pure. What if I want to know what is in there? So far I'm just checking if it's pure or not. But you can use chromatography to know what is in there. So let's suppose I have 2 things. So for example, I'll give you an example. Paracetamol is an performance enhancement drugs for horses. So if you want to know if a horse has been injected with paracetamol, then what you should do is grind some paracetamol and put that on the baseline here. So that's my pure thing that I want to know if it's in the sample that I have. Now, let's suppose these are some samples from a couple of horses and I just spot them there. This is A, this is B, and this is my original thing. I'm calling it paracetamol. Now I dissolve it, I dip it, it's going to dissolve. It's going to show up as multiple spots. So let's suppose my paracetamol shows up over here somewhere and B gives me multiple spots. It's not a pure thing, but it shows up like this, and A shows up as a different thing like this. Okay, so that's one sample, one result that I might have had. Why does water travel up? It doesn't really defy gravity. The reason any solvent travels upwards is, number one, solvents, when they dissolve into things, they are pulling on the previous water particles. So if I'm talking about water particles attract each other, right? So if it is dissolving into a paper, it will pull on other water molecules that are close by. And those forces, we call them adhesive forces. They pull them together, they make them go up. And then water is going to flow. So there's only one way it can flow, upwards, because that is where water isn't available already. That's why it continues to go up until a certain level where the capillary action stops, or it cannot go over there. And that is when it stops and gives us a solvent front. If you want to read more about it, I would suggest you read up on first intermolecular forces, hydrogen bond, again a word from A levels, and then obviously you can fully understand what capillary action is and how it works. All right, coming back to our example. So here's the thing. There are 2 tests to know if something is present in the other one. Musfa, we don't say that pure things have one kind of element. We say they have one kind of particle. All right, coming back. If I want to know if paracetamol is present in there, I have 2 ways. One is I do a very simple horizontal line test. Now that's not in your book. I just made it up, but it works. Horizontal line test means that if you want to know if paracetamol is present, draw a line through paracetamol. Now this line, wherever it intersects, that thing is also paracetamol. Okay, so that means A has used paracetamol. There you go, but B hasn't. B has a spot that's really close, but it's not paracetamol. So I will say that A is the one that has gotten that drug. Now the second reason is, second way, which is more rigorous, is if I want to know if it has it, then what I will do is I will calculate the RF value. I'll measure the RF value of paracetamol, and then I will find the RF value of these spots in A, and then I will know that if the RF value matches, then it has used the drug. Now, if you notice, these 2 spots are roughly on the same level, for A and B. Now this shows that A and B both have one thing in there. There's one thing that is common in both of them. We don't know what that is because we don't really have another sample of pure thing, but it does show that A and B have something in common. All right, so horizontal lines help us identify what is same and what is different in different samples. Now let's suppose I use a third sample and that was over here. Let me call it C. I did the chromatography, the sample didn't move. The spot stayed where it is. That means it is insoluble. Okay, so that's one thing. Now let's suppose I remove this thing and I take another sample, let me call it D. I put D here and I run the chromatography. And what happens is that after a while, the D spot has gone from here, but doesn't show up. Now that means it is colorless. And I will use something that usually does a redox reaction with it. We'll talk about it later. I will use a substance that if I spray on this thing, it will show up, it will give a color. So maybe it gives a color here. Okay. Now this is telling me that this thing was giving colorless spots. Whenever you have colorless spots, you use locating agent. So locating agent is a compound. You don't need to memorize any locating agent. I know there's one written in the book by Prescott, ninhydrin. You don't need to remember that. So locating agent is used. KMNO4 is also a locating agent. Again, you don't need to know it. You don't need to memorize it. I don't know, some students always come up with these names. You don't need to memorize them. Locating agent you use when you have colorless solutions. Okay, so if you have colorless spots, you spray the locating agent, it reacts with it, shows up as a color. So for example, in ATP, they might say that 3 amino acids are being tested. So obviously amino acids are soluble in water and they don't show up as colors. So we will use locating agents over there. So if you're answering, if you're giving a description of how to do chromatography, mention locating agent. So 4 things in chromatography. Number 1, thing must be soluble. If it is not soluble, it will not move. Number 2, baseline should be drawn with pencil. Number 3, RF value should always start from baseline and end up with the spot and then with the solvent front. That's how you find the RF value. And 4th thing, if you have colorless spots, use locating agent. And of course, this tells us that it is pure substance because it has just one kind of, or just one spot. For example, in the case of paracetamol here. All right, so that's how I know. All right, any questions about chromatography? So Ryan, yeah, these are ratios. Of course, RF values depend on solvent and the solute that we're using. So if you use a different solvent, RF value will change for that same thing. Because here's the thing, chromatography depends on solubility of things. If things are soluble to a greater extent in water and lesser extent in oil, obviously the RF values will be different. The purpose of baseline is to tell us where we spotted the actual, where we started, because once the thing is dissolving, the original spot is going to go away. So the purpose of baseline is to tell us that this is where you actually put it before you started the RF value. You started the chromatography. Because once chromatography happens, the original spot just dissolves, goes away. All right, so now we know what pure things are and how we can test it. There are some tests you need to know. For example, you need to know what is a test for water. So water, there are 2 tests for water. First one is that you take copper 2 chloride. So copper 2 sulfate, sorry. So copper 2 sulfate, when it is without water, which we call anhydrous, it is white. But then it changes to blue when you add water to it. We call that hydrated. So this is anhydrous and that is hydrated. So that is one test of knowing whether you have water in there. Of course, it doesn't tell me if it's pure water or not. For purity, I will always have to boil it to see if it's boiling at 100, if it's melting at, if it's freezing at 0. All right. But I can still check if water is there using this. Similarly, there is the cobalt chloride paper. So cobalt 2 chloride paper, which is blue and it goes pink. So if you add water to it, it goes from blue to pink, and that is how I know that I have water in that thing. All right. So that is testing for water, and that is the experimental evidence for that. Now the third thing is experimental design, like whenever you're doing measurements. All right. So measurement, obviously they are a big part of your ATP, of your lab training. So here's the thing, you need to know what we use for different kinds of measurements, okay? So for example, we have all kinds of things for measurements, and the four main things that we need to measure are time, we do that with stopwatch; temperature, we do that with thermometer; mass, we do that with balance. The usual unit is grams. For temperature, the usual unit is Kelvin or degree Celsius. In the lab, we're usually working with degree Celsius. And time, obviously, we measure it in seconds, sometimes minutes, especially when the reaction is slow or you have to get intervals of minutes and all that. And the fourth one is volume. Now, we have a lot of glassware in the lab to work with. So it's important to know which one is more precise, because that determines how good our measurement is. So there are three main things whose uses you need to know. The first one is measuring cylinder. Now measuring cylinder is that long column, and measuring cylinder goes like this one. I'm going to draw a rough diagram. So this is a measuring cylinder. It has markings on it. These markings are called graduation. So there has to be graduation if you want to measure something. If you draw something without graduation, you can't really use it to measure anything. Now this is a measuring cylinder. As a general rule, the wider something is, the less precise it becomes. The second thing that you need to know about is burette. Burette is that thing with the tap. Okay, so burette is that thing that has a tap in it. So you control it, and it is quite precise. And then you have pipette. Pipette is usually the thing that has just one point. Okay, so let's suppose this one point. So the pipette, that of course there are pipettes in the lab that are more like you can use them to measure different values, but in your exams, IGCSE or O levels, you're going to get the pipette with just one spot on it, which is telling me that this is very precise, but it also gives me that I can only measure a fixed amount. So for example, in the exam, they might give you an MCQ that which of these can be used to measure 25.00 cm cube. Now that 0.00, don't ignore it, because that's telling me I need to be very precise. So I could use a pipette. Pipette gives me 25 exactly. Pipette gives me 10 centimeter cube exactly. Burette can give that, but burette can also give 12. Burette can also give 12.5. So burette has that flexibility, and I can control it. But because of that control thing, it introduces some errors to the process. Okay, because I can control it, that means there is going to be human error if I stop the tap and all that. There is one more that sometimes we might want to use, that is a volumetric flask. Now volumetric flask has a narrow neck, not really close like that. That's just my drawing. It has one tap, one mark, just like pipette, and that makes it really useful whenever you dilute things. So if I want to make a solution of something, I will, for example, I have 10 cm cube of something and I want to add 40 cm cube of water to make it a total of 50. Now I will add that 10 cm cube to my volumetric flask, and then I'll add 40 so that it total becomes 50. Now I will take a 50 cm cube volumetric flask. So then I will be able to fix the volume that I get, and I will be able to get a very precise value that total is going to be 50. There are no other markings to confuse me over there. There's one more that we use in the lab, and that's not for volume measurement, but that's for different purpose. That's called a condenser. So a condenser goes like this. This is a condenser that we usually use. So it looks like a stomach, and of course this is like this. Now here's the thing. Here's the point. You push water in where you want the liquid to come out, because there's going to be a liquid going into that tube that you have, and the thing outside this water jacket or condenser, that is being used to cool whatever is inside. Now a couple of things. You can't cool something if it is at a temperature above boiling point of the liquid you're using. So for example, you use water. So I can't cool something that is at 150 degrees Celsius using this, because water inside my water jacket will boil. So you can't use that. Number two, if you want to use a water jacket, see which side you want the liquid or the vapor condense to come out. So if I want it to come out over here, I will push water, cold water in here and out here. So it's important to label them. There's another idea that they give in the exam, which is about reflux condenser. Where is the reflux condenser used? Let's suppose I want to do an experiment in which I have to heat a liquid. Now, if I heat a liquid, it will just evaporate. I don't want it to evaporate. I want it to react. And I can't really seal the thing, because if I seal it, pressure might rise and the thing might explode. So what do? I use a reflux condenser. Reflux condenser goes like this. I will take the same condenser and I will attach it to, let's suppose, this boiling flask. This is a boiling flask, the round bottom one, and you heat it. Okay, I'm heating it. Now the liquid that evaporates, it will go up and then it will come back. Why? Because the condenser is going to cool it. Now you have to see which side you want the liquid to come out at. All right. So if you want to come out, if you want it to go away, then of course you can put the water in from the top. Okay. But if I want the liquid to come back, then what will I do? I will make sure that water comes in from the bottom. Water comes in from the bottom, goes out from the top, because then only will my vapors drop back. Okay, so it's important where you label them. All right, so that is how you attach different things in the lab, and that is how you work with in the lab. So I'm going to give you a 5-minute short quiz now. Go on, try to solve these and tell me if you're getting your answers right. I will of course check whether you're getting it right or not. Now these are easy level questions. Now this is just it is actually 29 questions, but I'm going to give you a 5-minute quiz. Just give me a minute, let me make that quiz. I would like to make a big shout out to pastmcqs.com. They have helped me make these tests, and I'm really thankful to the team there. They're very supportive. All right, so I'm giving you 10 MCQs and I'm giving you a few minutes for that. 5 minutes should be enough. Okay. So I'm sharing the link here. Go on, attempt it. The link is in the chat. I'll see you in a few minutes. If the link doesn't work after you sign in, then maybe double press the link again, because the first time you sign in, you might want to go back and reuse the link. All right. All right, so let's review the quiz that we just had. So the first question was that oxygen was prepared from hydrogen peroxide and collected as shown. Now, gas collection is something I've already touched upon in previous lessons, but I'll quickly go over it again. There are three ways of collecting gases. One is that you collect them using delivery, upward delivery, downward delivery, or collect it over water. So when you collect it over water, you have to make sure that the gas should not be soluble or reacting with water. So of course we don't deal with things that react with water in O levels or IGCSE, except for cobalt 2 chloride and copper 2 sulfate. But the rest of them, just make sure that whenever you're collecting a gas, that gas will be damp, because water vapor is also going to be there. So you might need to dry it. Now there's one drying agent in your syllabus, that's concentrated sulfuric acid. Concentrated, not dilute. Concentrated sulfuric acid absorbs water. So this being over here, because we're collecting oxygen, we find that collection of water is the best method. The other two methods, downward delivery and upward delivery, work based on the MR of the gas. So if the MR is lower than 28, remember, lower than 28, it will be collected easily by upward delivery. Greater than 32, then it will be collected by downward delivery, like carbon dioxide or sulfur dioxide. But ammonia or hydrogen, that's upward delivery, that's below 28, their MR. Why 28 and 32? Because air is mainly nitrogen and oxygen, and nitrogen is 28, oxygen is 32, so gases that are roughly comparable to them, we try to collect them over water as long as they don't dissolve in water. So ammonia you can't even collect using water, because even though you can collect any gas using collection of water except for the ones that dissolve, ammonia will dissolve. So that's why we don't use this method. So what's happening here is they're saying that very first use were rejected because the gas was contaminated by water vapor, of course, because you are going to get water vapor inside the thing. All right, so that's important to know, that you're going to get water vapor in there. All right, which method could be used to obtain charcoal from a mixture of powdered charcoal with sodium chloride? So you have a soluble thing and insoluble thing. So you will use B. You will filter it, then shake with water, because that is how you can easily collect it. Of course, how did I come up with that? I'll talk about that tomorrow. Oxygen was prepared. This question is being repeated, so sorry about that. Next, the table gives the properties of four substances. Which substances is a solid metal at room temperature? So again, this is about melting point, okay? Room temperature is 25. So here's the thing. Try to figure out where 25 comes in over here. Now, I have a way of doing that. I put 25 either below or above based on where they are. So for this one, 25 is here. Now remember this thing. This thing will be solid here, liquid in the middle, and gas over here. So solid, liquid, and gas, and in the middle you have melting point, boiling point. So for this one, it's 25 is over here on the left side. It will be solid. For this one, solid again. This one, solid again. This one, liquid. Okay? Now, that's how I know the states. The first three are solids. Then I want to know if it's a metal or not. I know that metals conduct electricity when they're solid. So out of the first three, B is the only option that works. So B is my answer. So I'm talking about properties. I'm talking about melting point, and they have basically involved bonding and purity and experimental techniques in this MCQ. Alright, a sample of pure substance is heated until it is completely molten. Okay, so it melts, and the compound is then allowed to cool until it is completely solid again. Okay, so you heat it, then you cool it. So that means this is what's happening. When are both solid and liquid available? We talked about it yesterday, that whenever it's melting, both the solid and liquid are there. And how do you know it's melting? The temperature doesn't change during that. Why doesn't it change? Because energy is being used to break the forces. So Q to R, this region is where the temperature is constant, where both the states are present. Which of the following is not a mixture? Ethanol has a formula, right? It's a compound, not a mixture. Petrol, mixture. Steel, mixture. Tap water, mixture. Steel is carbon, iron, and maybe some other thing. Sometimes we add chromium, and obviously depending on how hard or how useful we want it to be, you add different things in there. Petrol is mixture of hydrocarbons. So that's why ethanol is the one that is a pure substance. Which reagent could be used to distinguish between dilute nitric acid and dilute hydrochloric acid? This question is about, again, experimental techniques, but about identification of ions. I'll touch upon that later on. So for now, I'm leaving this question out. I did see that two students got it right, which is a good thing. I'm happy for you. And then last question, a chemist wishes to separate and identify a mixture of substances using paper chromatography. The diagram shows the apparatus used. Okay, so this is paper chromatography. Solvent, as you can see, is below the solvent line. And you can clearly see that this is an impure thing because it has given us so many spots, 5 spots. So solvent front is allowed to reach the top of the paper before the chemist removes the removes the paper. So wait a minute, what's happening here? You are taking the mixture and you're allowing it to keep on going on for as long as it needs to, or as long as it can. And the problem with that is that now you have lost the solvent front, right? You have lost the solvent front, which means that you can't really use this method to figure out what the value is. Or so it's important that you know whether you can do that or not. So what do you think? Now let me see what most students answered. So yeah, this is the exam detail. Interestingly, this was the question that was the most time consuming for students as well. On average, you guys took 56 seconds to answer that. Now that's nothing to worry about. As long as we are below 1 minute for every question, that's perfectly fine. For example, in question number 3, it took on average 11 seconds to solve that. So you see, some questions are easy, some questions are more difficult. So as long as you do it, that's perfectly fine. So yeah, coming back to this question, what are the options? The options say that this causes the spot nearest the bottom to catch up with the spot above. Could be possible, but why would it do that? The RF value is fixed, so why would it do that? Next, this makes it impossible to calculate RF value. That is correct. You can't calculate RF value because your solvent front is now lost. This makes it impossible to use a locating agent. Not really. Locating agent depends on the color of the spots that you have, not these things. And this results in a safety hazard caused by solvent fumes. The beaker was open. If there were going to be solvent fumes, they could have just gotten up over there as well. So the result was good. I wouldn't say the result was bad because there was one student who scored 2 marks, but most of you were able to get 6 or closer to the higher value. That's fine. We are just starting out. This was the first test. I will try to make sure that we have a test like this in every class, so you are able to make use of what we have learned. But yeah, that was it for today. I will talk about further techniques of purification tomorrow. So I'll see you there. Thank you so much for joining in. If you want notes, if you need anything like notes and problem sets, tests, or even past papers, I put them on ahmedbokhari.com. Yeah, thank you so much for joining in. If you have any friends who are appearing for June 22, I would implore that you should also ask them to join in, because inshallah these classes will help them as well. Thank you so much. Allah Hafiz.